Okay, colleagues and guests, thank you very much for your time. We're going to get started right away. Good morning and good afternoon, wherever you are in the world. My name is Michael Frantz. I work for T-Systems, and today I'm going to be hosting our webinar event. We've got two exciting speakers for you today. First up will be Sasscha Leidig from T-Systems in Germany. He will be talking to us about digital twin. And directly after that, we've got Maged Elaasar from the Jet Propulsion Lab linked to NASA. And he's going to be taking you through the CESA, Open CESA and CESA topics and how NASA uses these technologies to achieve success. To kick off with the process, I'm going to be sharing with you just one or two introductory slides, and then we can get going from there. T-Systems. When you look at who is T-Systems and what we do, many people in the United States will know our T-Mobile business, which is our mobile network operating business. T-Systems is the enterprise IT division of the same group, being Deutsche Telekom. We have 4 big blocks in terms of how we talk to our customers to help them solve problems. They're on the screen, being connectivity, which is really our foundation block, our digital business, where we work with new service models, modernized and IoT applications, data intelligence. Security in the IT space is important to and critical to many of our solutions and what we do for our customers, and it forms a big part of that. And then cloud and infrastructure. When we do great things, where do we put it, and how do we help our customers achieve that? We employ some people. We try and make some money, and hopefully we sell it for more than it costs us, and that keeps us in business. We're truly a global business, and we're very proud of our track record in helping large organizations across the planet achieve success. When we talk about why does T-Systems have a seat at the table in this space, this is a very busy slide. I want to start really at the bottom and work our way up to the top. T-Systems has for many, many years presented a vendor-neutral approach to the traditional PLM market. We have great partnerships with most and many of the major players in that sector, and we have developed and deployed a number of exciting solutions and areas within the space that really help us. I'm not going to list all of them out, but what this has led to is that we have a great list of customers that we help around the world with many, many topics. And today we're going to be focusing primarily on 2 areas, and that sits within our linked data, digital thread, and twin, and then we'll talk about CESA in a couple of minutes as well. And with that, I'm going to stop talking. I'm going to ask Sasscha to take over presenting. I'm going to stop sharing my screen right now, and then we're going to get into it. Thank you very much for your attendance, and we will take questions on the chat. Please go ahead and help us, and we can go for it. Thank you very much. Sasscha, over to you.
Yes, hello everybody, good day. Warm welcome from my side. I would like to present you a promising and pragmatic approach to linked data, which goes beyond the classic data integration, data exchange. We make data being distributed over several systems logically traceable and usable in a digital twin. The approach fits in very well with grown system landscapes. So there's no need for complex integration or modernization of underlying systems. So no long-term projects to integrate all your legacy systems to link this data. Our purpose is to help you implement integrated use cases also in engineering in an easy way. Use cases could be in engineering, a faster evaluation of change requests, an efficient traceable product validation, or another example, the monitoring of compliance with specification requirements, like monitoring of the weight of a car or a machine in the engineering process. At the end, this saves costs and time, especially in the Corona age. So I have to share my screen. Okay. I hope you can see my screen. So our motto is we link your data. And why? What is the reason for this? Let's talk about digitization. We all know the unlimited possibilities of digitizations on the one hand. On the other hand, we all know digitized processes or business models rely on continuous data. And yes, when we look at the right picture, we know that's reality. We all, for sure, we also as Deutsche Telekom have yes, grown system landscapes with data and systems logically decoupled from each other. And at our customers, we can see data silos that lead to high complexity, outdated data, or a lack of flexibility in modernizing your business. This is the big challenge today. And this then leads to the fact that, for instance, the software of a new vehicle or machine is not ready in time or does not fit to electronic components. It can even get life-threatening. There have been incidents where pacemakers needed a software update for fixing a defective circuit. And by the way, in this example, years later, how can you give evidence in a traceable way that you have developed and produced this pacemaker in a correct way? So my conclusion is the increasing complexity of products can push existing processes and system landscapes to their limits, and that's what we want to address with our offering. And when we look in the engineering area, we can see also a lot of data sources. Typical automotive suppliers, what I know is they have 200 or 300 engineering systems, including Excel files, and traceability is the key word. Is only possible along the value chain with consistent data. And enabling traceability allows a wide range of questions to be answered in the and processes to be optimized, like when we look at these requirements, which could be stored in doors, which requirements were implemented by which concrete parts or software components, how did we test or these requirements, under which boundary conditions were simulation and testing done, is verification and validation consistent, what potential effects does an engineering change request have on production or the supply chain? And the answer is combining all this data in a logical or semantic way, and which creates the so-called digital twin. This is a digital representation of a physical product or process over its entire life cycle. It's more or less a data model which enables traceability in engineering, production, sales, after sales, and so on. So you can navigate through your whole supply chain from requirements till software development, production, and so on. And besides, to give a closer definition, if you have not produced a physical product yet, you could also call it a digital thread, which is a continuous information chain. So when we talk about the benefits of this, I talked about use cases to give you some examples. What could be done with this traceability, with this traceable information model, which we can see at many companies, and for instance have implemented at General Motors in the US or at Daimler in Germany, creating a linked data layer connecting a lot of engineering systems, SAP, and so on to each other. And you can create a lot of use cases in many industries. For instance, the first one is the cross-domain change management with an impact analysis. So this means you see all the related aspects of a change in one place: affected requirements, functions, parts, software, tests, costs, and so on. So no more need to do a kind of detective work, go to all the source systems, grab this data, combine it in an Excel and so on, and then doing the assessment of this change request. We're in discussion with a supplier who told us for the big change requests, he needs several weeks to do the assessment, and he has the vision to reduce this lead time to 1 day. Next one is as an example, use case is the efficient and traceable verification and validation in the means of what did we test in the past, and what can we learn from past tests? How can I save tests in the future because I tested a similar variant in the past? Or even, can we predict test results when boundary conditions change? And what we have at Bosch in place is a data layer which they use as a Google-like engineering search engine. So they, for instance, they can enter a part number and they get results from all systems where this part number is stored, like SAP, a PLM system, or even in a requirements management system. They can click on this result and then trace through all these information artifacts. Or they use it for baselining their engineering process, or due to legal or to federal compliance, with the press of a button, they can report which proportion of specific or critical substances are in their global products. So this goes on. You can also make a link to field data. For instance, if you design some components and you get the feedback, okay, your components, they cross some limits, some temperature, for instance, or they get defect, you can trace back and ask yourself, okay, which were the assemblies, which were the parts, where did I produce this part? What was our verification and validation? Did we have the right test cases or conditions when we tested this part? And you can correct this. And now think for a while for yourself, what would be possible at your company if you put together all this data from different legacy systems without the need of hard integration? What would be possible if you combine this data in a logical way? And yes, to help you create some ideas, I will give you a short demonstration. So let me just which we do with a software of one of our partners. We, as T-Systems, we are vendor independent. So this is one bottom-up approach with this tool or this framework. You start with what you have. With our customers, we define the most compelling use case to start with. We ask our customers, why do you want to combine data? What questions should be answered? Which insights do you want to gain? Which processes do you want to streamline? And then we extract all this data from the legacy systems, which I will show in a moment. So you see here this motorbike. Behind this user interface, this cockpit, is data from different systems. For instance, we can look at the part status, which parts are released, which parts are in work. You see this known V model in engineering with some of the existing information objects, parts, simulation results, tests, assembly tests, requirement tests, and so on. And if we go in a part, let's take this exhaust rear. We can see some metadata, and on the right side you see some linked information objects. So this part has some assembly tests. It has an engineering change request, but let's change to another view. Moment. So it takes a while. So you can navigate to a linked change request, which tells us, okay, you have to correct your design. It's too close to the driver. And let me just check. There should be a graphical representation. Yes, there we are. So you see the linked artifacts. We can navigate through the to the assembly. This is the exhaust components. We can navigate to this red one. This is the change request. Or we can even go, if you have some a colleague being responsible for the powertrain, you can navigate to all the powertrain and have a look which data is linked to this, which tests have we done for this powertrain, what is the powertrain system model we created in an authoring tool like Cameo, for instance. And that's the so-called, we call it linked data, or in this case, a digital brain. So you have all your data in the value chain linked. And going back to the presentation and coming to my summary and conclusions. So what you can see at the bottom is the classical integration. We as T-Systems have been doing this for more than 20 years now. We have PLM integration products for this, which we license to companies all over the world, to the US, to Asia, and so on, helping in scenarios like migrating data from one PLM system to another system, or synchronizing this data, exchanging this data. At a customer, we integrated doors with SAP, with Enovia, with Teamcenter, with Windchill, and with Integrity as ALM software from PTC. So that's the classic way. You're doing projects with this. Our products help to accelerate these projects because it's a well-proven project. You can do everything with configuration, no need to program these interfaces, and we use the native APIs of the software systems. And the new approach, which we more and more see in the market at big players, at big OEMs, also at many suppliers, is that they say, okay, we want to go for digitization, and this classical approach it will be still important, but it's too heavy. So, and what we do is we align on the use case with our customer to start with, and we talk about corresponding data sources and important business objects, and how these business objects relate to each other. then we extract the metadata on a regular basis from these source systems, and we do a semantic data modeling and linking across system boundaries. And that's where the digital thread or digital twin is born. And we do this in an agile way, so our customer can see on a weekly or daily basis our approach, and we discuss this data network. Is it right? Which relationships are missing? Do our customers have some gaps in the data? And at the end, we visualize these use cases in role-based cockpits. So like a cockpit for monitoring the weight of my whole product and different parts, or assessing change requests and so on. So that's it from my side. And when it comes to semantic data, semantic web, I hand over to Maged Elaasar, who is an expert in this technology and methods, and with his framework, OpenCaesar.
Thank you, Sasscha. I will share my screen. I think you may want to unshare.
Yes.
Okay, great. Share my desktop. Okay. Good morning or evening, everybody. My name is Maged Elaasar, and I'm a software architect at the Jet Propulsion Laboratory. And today I would like to talk to you about a project that I'm leading at JPL, whose mission is to modernize the practice of system engineering. And what you will be hearing from me today is very consistent with the message that Sasscha just provided, using semantic technologies and linked data in order to modernize the practice of system engineering. All right, so I am going to just survey a little bit the pain points of system engineering that's calling for this modernization. You may notice that system engineers, they work with a lot of documents. So they capture the requirements in those documents. And unfortunately, this is good for human consumption, but not for machine verification. They can very easily get out of sync. You don't know where is the official baseline, and so forth. System engineering involves a lot of domains and disciplines, but these are not very integrated with each other. A mechanical aspect could affect propulsion or thermal, but without like a disciplined attempt at integration, you may not know the proper impact of the change. In a big organization where a lot of projects are happening, these projects tend to take time and they become silos. You produce products in one project, it's not reusable or consistent across the other projects. And when engineers try to use tools when they try to fix this problem, they focus too much on the tools and they forget the methodology, how these tools should be used together. And even those tools are very poorly integrated. They usually come from many vendors, and there wasn't a coordinated attempt at integrating them in the context of a particular methodology. Silos exist within the projects, and these projects, when they carry on their engineering effort, they need to coordinate because they usually work in silos. So these coordinations happen very infrequently, and when they do happen, they don't happen in a methodological way. System engineering is about producing products, but if these products need to be maintained manually, they become stale in no time, and it becomes very hard to know where to go to access these products. And of course, a change is inevitable. And when you perform a change, if you don't have a well-disciplined and automated approach to do change management, it will lead to chaos. Of course, with change come the need to configuration manage, and these practices are not very, they are poor to say the least. And of course, to do compliance and to check history, the project needs to have kept all the history, and these practices are also not very, not done properly. So like I would characterize the system engineering status quo is mostly document-based. There has been some attempt to go into this modernized, so in document-based world, most of the system engineering happens in the office products. Excel, for example, is the most used one. But the notion of model-based, which is let's capture these information into machine processable and formalized fashion. This is what model-based system engineering is about, and there has been some movement towards this, and a lot of tools have popped up to help with that. But these tools are siloed, they are not integrated, and certainly they don't know the methodology of the organization. What we want to move to is this integrated model-centric engineering, where all these tools have been taught the methodology of the organization, and they are helping the organization practice its methodology in a coordinated fashion. So at JPL, we recognized this problem very early, and we've started an R&D program to fix it. The program's flagship product is called CAESAR, Computer-Aided Engineering for System Architecture. So JPL is developing CAESAR as a platform for system engineering. And as a platform, it's meant to be extensible. What you use it for is define your own methodology on top of it that works for you. And then once you define it, all your projects that need to be done in the same way can use this methodology. And this is exactly what we're doing at JPL. Some high-level characteristics of this platform, that it's using linked data and semantic web to capture information. It's capturing the information not according to what the tools say, but according to to your methodology. So you have to start thinking like, how do I want to do business, and encode that into domain-specific vocabularies that capture the meaning of the information. And these are semantics, so that you can not only say the information will look like this, but what does it mean? And we agree on it. The tools that we use have to be taught this methodology by either like adapting existing tools or creating new ones. So the platform supports both cases. And it supports all the collaborative use cases of configuration management, version management, linking of information, and reconciling the information. And we are bringing also this culture of DevOps from software engineering to work well there to systems engineering, so that there is always this process of continuous integration, continuous delivery, making the products accessible. So the architecture of CAESAR, in a nutshell, is what you see here. This box represents the ecosystem of tools that are used for system engineering. There is a lot of existing tools that you already use, authoring tools, reporting tools, analysis tools. The job of the CAESAR platform is to adapt all these tools to work together in a coordinated way, such that you can support the effort of describing the information that the system authors are using these authoring tools to describe the information. And on the other hand, you have the stakeholders who want to consume the information. They want to consume it in meaningful ways. Sometimes these ways may not be exactly the ways the authors have expressed them at. For example, you could be using Maged Draw to describe your architecture using SysML, but your system stakeholders are interested in how does the mass of the system like roll up? Do I have a power source for every power load? These are the kinds of views our system stakeholders are interested in. They may not be necessarily SysML experts. So this platform allows you, it is generic. It provides several functions, for example, the authoring, the linking, and the synchronization are on the left-hand side. A set of services in the middle allow you to do integration, analysis, using tools, and then the reporting function for the stakeholders. The platform is generic, and it can be customized by a set of applications on top. These applications, think of them as the components of your methodology that you start building up. Okay, I'm not going to describe in detail the technical stuff of how this is done. I would rather keep it at the use case level. What problems does it solve, and how the approach is going, and then I will be glad to entertain questions about the details later. So the first use case I want to describe is this federated authoring. The problem this is meant to solve is we have already a lot of teams on a project that are doing different activities. Some of them doing requirements, some of them are working on architecture, some of them are doing specific kind of requirements like electrical, and some of them are working on design. And as you can see, they are working in silo in different tools. Now, if we want to make sense of all of this together to understand what's going on, it's very hard to do that in this format since they are in different formats, different schemas. What we need to do is to normalize them. But how can we attempt to normalize them without understanding of how they are meant to be used? So that's why we start with defining the methodology with a set of vocabularies, semantic vocabularies that define the concepts, the attributes, the relationships between them in a semantic way. And then we can normalize each one of these data sets from their tools into a common normalized format. And we put all of this into a configuration management databases or repositories. In this case, I use Git as a very popular repository technology that supports all the modern configuration management features. So the authors are still working on their native tools, but whenever they want to promote a change to be integrated, they push a button, it gets normalized, it gets in this normalized form in this data set, which will trigger an analysis or integration pipeline that checks this change and reports it to the stakeholders. So, and in this case, there is no assumption that we need to have one tool to be used, one repo. The assumption is they could be doing in parallel as long as we can check how they are consistent with each other and fix any problems as soon as possible. And of course, in teaching these tools how to work with the methodology, we may need to customize them a bit. So for example, the Maged Draw out of the box does not know about the methodology we're using, but here we have mapped the methodology into a SysML profile so that I can be more specific when I model the architecture. I can say launch system, a block is really a component, and deliver flight is a function. And the relationship between them is perform. So component performs function. And this relationship has semantic meanings. I can derive inferences from it so that I can check the consistency. And that's just an example of how such tools can be adapted. The next use case is about linking and reconciliation. Of course, when you are dealing with a federated system, federated repositories, these things are not independent. They are related to each other. So these relationships need to be asserted. These assertions could be done in an indirect way, like using the same IDs across the tools, or they need to be asserted in a direct way, as in creating links between these data sets. So these links just become another data set to integrate. So you have the original data sets, and you have data sets that just capture the links between these original data sets. And all of them become the source where we start integrating from. And all our analysis capability will be done starting from this base, which gives us a good buffer between when these tools change. All what we have to do is just change the adapters, the normalization process. But all our investment in analytics happen from this methodology-specific format, which should have a more lifespan than these individual tools, which can be replaced later. So, of course, when we integrate, we may realize they are out of sync. These repos are out of sync. We need to fix them. So this tool also can fix them, can take a state of one dataset and transform another such that it restores the consistency back. A third use case I want to talk about is this custom authoring. So sometimes if my methodology is well supported by tools, then I'd be happily using those over-the-shelf tools. But sometimes it's not. There is this part of my methodology that is not well supported by tools, and I wish I had a custom tool. Most engineers with this situation will resort to using Excel as a tool to do with this custom capturing of information, with all the problems that can create, being imprecise, how to share, how to collaborate. So the platform allows us to realize new authoring tools, directly know our vocabulary or our methodology. So it's very easy. So we can make it look as close to Excel as we want. If Excel is tabular, we can make it tabular. If you prefer graphical, textual, all these views can be done in the custom tools. And when you author in these tools, under the hood, you are still doing semantic linked data that can be checked, corrected by construction, and therefore avoiding all the problems of using tools like Excel only. The fourth use case I want to talk about is this continuous integration and delivery that I described earlier. So you have your data sets that have been normalized thanks to these the adapters that have read them from their original repos and put them into these normalized things. So when we talk about our baseline, where is the baseline? The baseline is actually federated. It's not only the baseline of one particular data set, but when we want to understand the state of the system, it's the baseline as captured by all these data sets together. So when I say master here, I mean that's like the baseline of each data set. So when there is a change to these data sets, we need to check the quality of this change that happened. And for that, we are allowed to write a script, a continuous integration script that launches analysis tools that check the state of the data set. These tools could be all kinds of things. Could be reasoners, logical reasoners. They could be simulation tools. These could be solvers. They could be analytics, statistical analysis. All kinds of things that can check the current state of the repository and manifest it or produce. They push their change to. They produce some artifacts and put them into artifact repository. These are like the canned reports that your stakeholder would expect. The MEL, the mass rollup, the power rollup report, the requirement satisfaction reports. All these expected reports can be produced by these CI scripts and pushed into an artifact repository that maintains all the versions. So you can see the most recent artifact or historical artifact. It can be also be pushing them into a graph database that exposes query endpoints that all sort of tools can ask questions to. For example, you can, with this query endpoint, you can invoke notebook technologies, visualizers, like Jupyter with R Studio, Tom Sawyer perspective to have a block diagram. You can. So the story here is that whenever we make a change to the baseline, we have a good understanding and we can analyze the change to see if it's consistent. But of course, we just don't change the baseline. There is a process. So when there is an engineering change request, let's say I identified a change request and I gave it a number, ECR42, and now I want to implement it. I have to see which repositories out of my tools that change will be implemented in, and I will create a branch of these tools, of the data sets. I created a branch of ECR42 here, which when normalized will become a branch of dataset 2. And then I run my CI script on that branch and see what is, how will this change affect the state of the system as judged by the reports. And we facilitate doing this by views that show you the was and is, like what is the exact change from an author perspective. So you can see, okay, this object got added, this attribute got modified, but you also get your updated reports so that you can see the new snapshot of these reports that will be resulting from this change. So that the humans, when they look at this change, they can look at it from their perspective, and you can automate as much of the checking as possible in these scripts. And of course, when you think you've arrived at a good milestone with dataset 2 in this ECR, then you want to also check its impact against other datasets. So you continue pushing your change down to integration repositories. This one checks how dataset 2 is consistent with dataset 1. And then once you verify that, you can push it, integrate a third dataset. So these integration repositories, you can architect them based on your methodology. What is the order of integration that you want to achieve? And you can set it up this way. And the tool will help you to like instrument all these changes. So these are the high-level use cases I wanted to share with you. There are others that we can talk about later. But I also wanted to bring your attention to that a good part of what you have seen that we've developed at JPL has been outsourced, open sourced in a project on GitHub called Open Caesar. So we have a blog for the site where we share our insights and documentation, and the repository itself is on GitHub, and we welcome contribution, and we also welcome engagement as in if you want to try the platform, we recommend that you set up a case study of using it. It starts by defining your methodology with some vocabularies, defining these data sets, setting up the analysis chains, and working through the use cases of the platform. I think this is it for my slides today. Thank you very much. I'm not sure, do we want to transition to questions?
Mike, you're muted.
Oh, sorry. Thank you, Sash. So folks, thank you for your attendance. We will take questions. There's a Q&A chat function. If anybody has anything that they would like to ask us about, I'm putting my details up as well on the screen right now. And you're welcome to get hold of me at this email address or make contact with T-Systems off the media platforms. We're happy to do follow-up calls with you and your team. What we've given you is a very high-level, 20-minute each overview of two different ways of solving similar problems in a similar environment. And we're happy to, of course, explore this in more detail with you at a later point, and we'd love to have that opportunity. But thank you again to Maged and to Sasscha for your contributions, guys. It was great. It's clear you know your topics and you know what you're talking about, and happy to do that. A question to Sasscha. The various types of data you showed in your demonstration reside in various systems. Is that correct?
Yes, that's correct.
Yeah. Okay, very good.
So for instance, I talked about General Motors. I think in the meantime, we have 16 engineering systems linked to each other, but not in this system integration way, using interfaces between all the systems and maintain these interfaces. No, we extract data from the systems, the metadata, not the CAD files, the metadata of all these information objects, and this metadata is transferred in this linked data layer with the defined relationships. And it's not a redundant information layer, because the master data is still in the legacy systems. It's just, let me call it, it's an information architecture to gain new insights and context about your processes and data, and to improve your engineering processes.
Mm-hmm. Maged, maybe you want to make a comment about that as well, in terms of various data
Yes, Caesar has the same architecture where the data is indeed mastered at the repositories that are managed by the original tools, let's say, and then these like if a normalized view of this information is pushed to Caesar, so that the analytics start from that normalized format, as opposed to starting from the original format, which can be like all over the place across all these tools.
Fantastic. There's a question for Maged. Maged, can you give us a comment around the commercial availability of Caesar and the thoughts around that, high level? And maybe the person who asked that question, if you could either reach out to me and we can take you through that process. But Maged, maybe you wanna give an answer to that question.
Sure. Yeah. So beside the open source project that exists for Open Caesar, there is like effort underway to transfer this technology into the industry at a commercial level and to support it. So in the near future, there will be commercial offerings around Caesar and support, professional support with partners like T-Systems.
Thank you, Maged, for that. For Sasscha, do you have any current experience with the manufacturing industry for digital twins? Can you explain a little bit of the benefits for the customer?
Yes, to give an example, in the manufacturing industry, you have your production planning data in SAP, and you have your machine data. And one benefit of linking this data could be the optimized interaction of SAP flowcharts and the machine data, avoiding unscheduled downtimes, or if you have some issues, use this traceability and walk through all your processes and find out what was the root cause of it. You can link data from MES sources either, and there's also a huge potential in this manufacturing area.
Thanks very much for that, Sasscha. I guess the question to both of us, to both the guys, maybe Maged first on this one and then Sasscha afterwards. What would you see as the main hurdle in an organization to move to a good methodical approach as shown today? Maged, you want to go first, and then Sasscha, you can jump in after that?
Sure. So, of course, culture is the biggest challenge in adopting this. People just resistance to change, to doing things in a methodological way. But if you think about it, they like everybody is already doing things in a particular way. It's just that this approach will help them do what they are doing already in a better way. So it's not like asking them, for example, drop the way you're doing business and move into this new methodology. On the contrary, we're working with them to understand how they are doing their work, and then we're customizing the methodology to fit their workflows. This way, they are not. We reduce the resistance. In fact, on one of the projects, we started like helping a team doing electrical engineering, and they were using Excel, and they were mixed results with that. So when we looked at their, they said, okay, we prefer Excel since we can have these tables. Okay, so we designed for them a custom tool based on the methodology that looks like Excel, so that at least from a user experience perspective, they're not like alienated on not having to change things. But then we started looking carefully at their data and suggesting improvements. Why you have this column here, why you're doing this, and with a good set of logical questions and answer from their part, we incrementally improved and sharpened their methodology and got it encoded. And then the tool just reflected that. So they became very happy. Now the information is much clearer in their head. The tool is assisting them, and then with the change management and version control, which is a game changer for them. They didn't used to do that in this way. I think they can speak very positively about the change in this format.
Thanks, Maged. Sasscha, do you want to make a comment on that?
Yes, I think Maged was the best to explain the methodical approach, because one might ask, okay, are these competitive or complementary approaches here? These are complementary approaches. So Maged has more a methodical top-down approach. He told us when you discuss with your engineering domains, you discuss a common vocabulary, ontologies, and this in the end leads to a new kind of systems engineering process with embedded agility, trade-off analysis, and consistency control. This has a lot to do with change, I think, Maged, as you explained. And the approach I demonstrated, it's a bottom-up approach. You start with what you have at the customer. It does not have the ambition to do some standardization or normalization. You link data pragmatically in a digital twin, and you gain new insights and context for your product development. But when you're doing this, you build a linked data, and you see your maturity of your data and processes and your gaps, and this helps to go to the next step and really do this ambitious approach from Maged, this top-down approach. And
thanks, Sasscha. We've got another question. Should we have a separate organization focused on data instead of using our current process organization? That's the question. Or should it be together to optimize resources and use process background? Have I got that right?
Sure, yeah.
Take that one. Go for it.
I can answer that from our experience at JPL. We see this effort as a collaboration between three kinds of organizations. The first one is the line organizations who have the expertise with the methodology and know how to do business. The projects, which are the practitioners on the ground who are applying those methodologies, and then the engineering IT office, or the people who are trying to modernize these approaches in collaboration with both. So we partner with the line organizations to understand the practice, to understand how business should be done, encode that into the Caesar platform as applications, and then we verify what we do or validate it with the practitioners on the ground. And that's why before we tackle one part of the methodology, we look for partnership, for partners, motivated line organizations who want to modernize their practice, and motivated projects who are eager to apply those things. Of course, everybody's time is precious, so we instead of starting off at random like areas in the methodology, we are like opportunistic. We look for the low-hanging fruit, people that are eager to do it. We make the change, we show the value proposition, and then the others just come because they see how partnering with us have helped the previous group. They are eager to also do that, and the chain goes on and on. It doesn't have to be done in a single shot. It's done incrementally.
So no big bang, Maged. I mean, that's what you're really saying, right? We start with one space, with what we've got, and we start the change within the organization and the way we work from a single point, right? Sasscha, maybe a comment from you, and then we need to wrap.
Okay. Yes, what I see in the market is that the engineering department, they all want to go on and in a best of breed approach, they want to use the specific tools, and also their own data sources. I saw that a big customer today. They were discussing about having one global data lake with all this data from sales, service, production, and so on. And they went back and said, okay, let's keep our decentral data lakes, and because every department has its specific requirements, and let's link this data together, but having no really central data management.
Mm-hmm.
But for sure, you need standardization following Maged's approach.
Thank you, Sasscha. And let's wrap because we're at our time limit. Folks, thanks again for joining us. Thanks again, Maged and Sasscha, for sharing what you know. We really appreciate it. If there's anybody who needs to get in touch with us, please do so. We're easily accessible. You can get me on LinkedIn or Maged or Sasscha. You can get us on our contact information we've shared. We will make this webinar available on our social media platforms for you to reshare within your organizations. And again, thank you very much. Aaron, I think that's a wrap from our side. Thank you.
Thanks.
Goodbye.